Okay, my last video got cut off on number 11. I do not know why that happened. So I will pick back up where you last saw me. I had talked about how these two vertical angles were congruent. And since I have two angles on this triangle, congruent to two angles of this triangle, I know that my triangles are similar by angle, angle. I know that since the triangles are similar, that the sides are proportional. And if sides are proportional, that means I'm going to set up a proportion to find the sides. Okay, the first side I want to find is x. So I personally, when I start my proportions, I start with whatever it is I'm trying to find most of the time. So x is what I want to find, so x is what I'm going to start with. And what would I compare x with? X is to 10 as, if I start with bottom triangle and go to top, I have to go back to bottom and then top. So x is to 10 as 12 is to 6. I cross multiply and divide. 6 times x is 6x. That equals 12 times 10, which is 120. If I divide both sides by 6, I get x is 20. Okay, next I want to find my y. So I'm going to start my proportion with y. So y is to 8. So I'm going to start it. Y is to 8 as, and if I start with bottom triangle, go to top, I got to go bottom to top. So y is to 8 as 12 is to 6. I cross multiply and divide. 6 times y is 6y. That equals 8 times 12, which is 96. And if I divide both sides by 6, I get y is 16. Sorry, you weren't able to see that there for a second. So 6 times y is 6y. That equals 12 times 8, which is 96. And if I divide both sides by 6, I get y is 16. Okay, my next one. I know that any time this segment here in the middle of the triangle, well, not the middle of the triangle, but this segment in the triangle is parallel to a side of the triangle, that it splits the triangle into proportional segments. So I know this little piece is to this little piece as this little piece is to this little piece. So I need to figure out what this little piece is. So if this whole segment here is 27, and I know from here to here it's 15, what would this piece be? 12. This time I'm actually not going to start my proportion with x. So I know that since these two segments are parallel, this segment here splits the triangle into proportional pieces. This piece is to this piece as this piece is to this piece. So I'm going to say 15 is to 12 as 20 is to x. And there's so many other ways I could have said it. I could have said x is to 20 as 12 is to 15. I could have said x is to 12 as 20 is to 15. Lots of ways. When I cross multiply and divide and I work that out, I get x is 16. I'm not going to show the work on that because I think it's really easy to do. This times this equals this times this. Work it out. Okay, number 13. Since this segment split this side into two equal pieces, I know that this is a midpoint. And since it split this segment into two equal pieces, I know this is a midpoint. So the segment that connects those two midpoints together is called the midsegment. We learned about that last 6 weeks. So I know that since it's a midsegment, this is a midpoint, this is a midpoint, so these two pieces equal, these two pieces equal. I also know that the midsegment is half the length of the third side. So if this is half the length of this third side and this side is 12, how long would this side be? This side would be 6. And if 2y is 6, how much is y? 3. Remember that? Mid-segment is half the length of the third side. So if this is 12, this is 6. 2y equals 6 and solve it. Now if I want to solve for x, I can see that this piece equals this piece because of the tick marks. So I'm just going to say 4x plus 3 equals 2x plus 15. 4x plus 3 equals 2x plus 15. When I have x's on opposite sides, I have to move them. So I'm going to move my positive 2x by subtracting it. When I do that, 4x minus 2x makes 2x. My plus 3 is going to drop. My equals is going to drop. That made 0. My 15 drops. Next, I would subtract 3 from both sides. And if I subtract 3 from 15, I get 12. And if I divide by 2, I get 6. So my x is 6. Okay, and my last page. I know that anytime I have 3 or more parallel lines and they're cut by 2 transversals, that the pieces get split up proportionally. This piece is to this piece as this piece is to this piece. This piece is to this piece as this piece is to this piece. So I'm just going to set up a proportion. 2x minus 7 is to x plus 3 as 5 is to 5. Now some of you may realize, hey, I could just reduce this and make this 1. Well, sure, I could do that. Or I could just leave it the way it is. Whatever you really want to do. If I just didn't even notice that that reduces to 1, I could just start cross multiplying. If I realize that that does reduce to 1, it would actually make life a little easier. If I say 2x minus 7 over x plus 3 equals 1 over 1, and I go to cross multiply, 2x minus 7 times 1 is just 2x plus 7, or minus 7, sorry. And that would equal the other diagonal cross multiplied, 1 times x plus 3, and 1 times x plus 3 is x plus 3. But if you didn't realize that this, could reduce to 1, which would make life a little easier, then you would just say 5 times 2x minus 7 equals 5 times x plus 3. No big deal. Now, the way I have my equation now, I just need to get my x's on one side. So if I want to move this x, I would subtract x from both sides. 2x minus x is x. I would bring down my minus 7, my equals, and my 3. And if I add 7 to both sides, I get x is 10. And that's my answer. X equals 10. So let me go ahead and put that up here. Okay, number 15. This says the ratio of the measures of 2 supplementary angles is 7 to 2. Find the value of x and the measure of each angle. Well, what do you know about supplementary angles? They add to be 180. So if the ratio is 7 to 2, I'm just going to put an x behind each of those. One of the angles is 7x, plus the other angle is 2x. And you said that supplementary angles add to be how much? 180. If I combine like terms,